All right, let's finish up that one example that we didn't get to yesterday, that one little section of a piecewise function. So we did two of them, right? We did that one, right, with the bus stopping and all that kind of thing. It was kind of like random, lines going this way, that way. And you had a domain, right? It was between this and this. And then we had the, the absolute value ones, right? They weren't so hard, were they? Figure out how to do the absolute value. This one, it's kind of weird. I don't know if I've done this before, and I've taught this before. I mean, years ago, probably. Last time I taught this stuff, it was at least 20 years ago. Probably, yeah, because I probably taught it maybe my last year. Yeah, so 20 years ago was the last time I taught this stuff. So I might be a little bit rusty on it. But we call it a step function. And what we're going to do is one type of step function is this one particular one. So this is kind of like underneath a step function. A step function could be all kinds, but this is one particular one, okay, one specific one, and they call it the greatest integer function. Greatest integer function. Now again, my explanation on like what it means might be not so great, but I'll show you how to do the problem. That's all you want to know anyway, isn't it? Just show me how to do the problem so I get it right on the test. I mean, normally I don't like that kind of attitude, but as far as this one, for right now, I think we're good. So you're going to see it. It looks like this. You put an X, and it looks like you got a bracket. Some people just write it with a bracket like this. But if you look in a book, I think they usually like put a line down like this and a line down like this. Kind of looks like a double bracket. Right? It's kind of different looking. So that's considered a greatest integer function. So if I wanted to graph like y equals, and sometimes they'll put like something inside of there, something outside of there. What we're going to do right now is just your normal basic everyday greatest integer function. So it's just going to be y equals the greatest integer of x. All right, let's talk about what that means. Basically, what it means is this. I'm gonna do a couple charts here. I'm gonna do from 0 and just do a couple a few positive numbers, and then I'm gonna do another chart. I'm gonna go negative. All right, so I'm gonna do it half and half just because the positive is a little easier to understand, and then I'll do the negatives. By the time we get to negatives, you're like, oh, okay, I think I figure out what's going on. So here's the definition of the greatest integer function. This is where I wish I could explain it better, but I'll show you how to do it. And the demonstration of how you do this problem should not be a problem. It's just the explanation of what it means. So here's what it means. It's in the book somewhere. When they first show that symbol, that bars and those symbols right there, or that bracket and that X. So it says it means the greatest integer not greater than X. So it's the largest integer that's not bigger than what's in that bar right there. Again, I wish I could explain that better. So what we're going to do is this. So if you have an integer, okay, the greatest integer not bigger than this, right? Because 1 would be the next integer, right? But it can't be bigger than 0. So what's the next integer? It's 0, right? It's right next to it. So 0 goes with 0. Now watch this. What if I put in like a 0.1, 0.2? I'll just go 0.5. Now, think of the number line. There's 0, and then there's let's say 1 is right there, okay? So I wasn't exactly right on this. So let's say 1 was there. Let's say a half was right there, okay? So the greatest integer means it's the greatest integer not greater than this. Okay, so what's the biggest integer that's not bigger than this? Well, it's not 1. Why not? Because it's bigger, isn't it? But is 0.5 an integer? 0.5 is not an integer. What are integers? -3, -2, -1, 0, 1, 2, 3, ... Those are integers. So 0.5 is not an integer. So listen, if I'm at 0.5 or a half, are you done? Come on, get it over with so I can teach. Interruptions all day long. I mean, I understand you got to blow your nose, but I mean, go outside or something, Let me teach. So look, if I'm at a half, what does the greatest integer mean? It means the greatest integer that's not greater than 1/2. So what integer, what's the largest integer that's not bigger than this number right here? It's 0, because 1 would be bigger, wouldn't it? It says it's not bigger. So 1 would be bigger. Yes? Okay. What if I put 1/2, what do I put for y? Put 0. What if I got really close to 1? What if I got like 0.75 right there, or 3/4? Then what is y? It's still 0. Okay? Because 1, it can't be 1, because listen to my definition. It's the greatest integer, the largest integer that is not larger than 3/4. So 1 would be larger than 3/4, right? The greatest integer says, what's the biggest integer not greater than 3/4? Well, 1 would be. So what's the next largest integer? It's 0. I put a dot. I just didn't write it because I didn't have much room. There's 3/4 right there. Okay? Do you see that? So everything between here all the way until you get to 1 is going to be included with the 0. All right? So watch. If I put 0.75, what would the y be? It would be 0. Right? I could put anything between 0 and 1, like 0.9. What if I put a 0.9 in for x? What would y be? It would be 0. So basically what we're doing is we're rounding everything down. Do you hear what I just said? So if I round everything down, that's what we're talking about. So I'm looking at this gap between 0 and 1. That's between my integers. So if I pick any point, like 0.25, what's the greatest integer, okay, of 0.25? Well, it's not 1, because that's bigger, right? What's the next one? It's 0. And it's not -1, because 0 is the greatest one, right? It's the largest one that's near that 1/4. Near that 1/4 is probably not the best way to say it, but it's the greatest integer not greater than x. So anything in here is going to go to 0, all right? Now, what happens when I jump up to an actual integer, like 1? What did I do when I had that integer 0? I just put the same. So if I put a 1 here, what's going to be here? A 1. Okay? Now, let's fill in between 1 and 2. All right? So let's go 1.25. We could have gone 1.1, anything. We could put any decimal in between 1 and 2, correct? So again, here we go. Here's 1. Here's 2. Where's this? 1.25, correct? So, and what kind of, I got 1, 1, so I could go closed in, all right? But what if I put like 1 1/4? That's 1 1/4 right there. So what integer is closest? I'll say that. I guess that's okay. What's closest to 1.25 that's not bigger than that? Right. So you can't use 2 because it is bigger. So it always drops back. See that? It always drops back to the integer before. So everything in here. So if any integer in between here is going to go to what on the y? It's going to go to 1. See that? 1.5 is going to go to 1. 1.75 is going to go to what? 1. You see that? All right, so now I think we might be ready to graph. So, oops, there we go. So let's do this. Let's make a little graph. Like this. All right, and I'm just going to do the positives right now. I'm not going to go real big. I'll just go 1, 2, and 3. I'll go 1, 2, and 3. All right, now let's do a different color. Again, let's start at the 0, and we're going to develop a pattern. Once you understand what this thing looks like, it's really not that hard to graph. All right, it's kind of hard to understand why it keeps going back. And that's because my lack of good explanation for it probably. But I think I did okay with that. So at 0, what do? Put a point, right? Everybody see that? Because 0 goes with 0. That's 0, 0. Would you agree? Yes? Okay. Now, it's going to do what all the way until it gets to 1? What did we do earlier? What's it going to... See, anything in here keeps going up to 0 on the y-axis. So what's it going to be? It's going to be all filled in, right? Up until where? Until you get to the 1. All right, so now watch this. This is a little bit different. So all the way till you get to the 1. So that's open right here. Now, once you get to 1, what does it do? It goes up 1, doesn't it? You see that? So at 0, you color it in. You go up to 1. It's open, right? Because this could go to 0.9999999, and it would still stay on that x-axis. Do you see it? But now, once we actually get to 1, what does it do? It completely jumps from 0 to what? To 1. And now, what's it going to do between 1 and 2? Well, if I go over 1.25, where do I go? I go up 1. If I go over 1.5, it jumps up to where? 1. If I go over 1.75, it jumps up to what? 1. If I go to 1.99999, it's going to jump up to what? Come on, I've said it like 10 times. 1, thank you. All right? Come on, you need to follow along. And it's going to go all the way to there until it gets to 2. What are we going to put it to? An open circle. Now what's it going to do? Now, anything between 2 and 3 is going to jump up to what? Up to 2. Good. All right, so it's going to jump up to 2. So 2.25 is going to jump up to what? 2. 2.5 is going to jump up to 2. 2.99999 is going to jump up to 2. All the way until you get to what? 3. And then once we get to 3, we get super, super close to it, but we never really touch it, so we put a circle there. Let's do the next one. All right, what about 3 and 4? I don't see a 4 there, but you get the idea, right? Let's say I had a 4. Whoops. Let's stay color coordinated here. What if I had a 4 right there, just to kind of keep going with the pattern? All right. All right, so now, watch. We're at, I should have put a 4 up here. I should have just stopped at 3, shouldn't I? But I got so excited about following this pattern. So what do? You go up to 3. Now, anything between 3 and 4 jumps back to what? To 3. So you put a 3 right here, and it goes all the way till where? 4. That's right. And then this is going to be open. That's what your steps are going to look like. You understand why they call it a step function? Look, boom, boom, boom. There's steps. All right? And that's what the greatest integer function is. I did it with the positives because it's a little easier to see with the positives. But now we can just kind of repeat that pattern with the negatives. Do you think you can? All right. So that's -1, -2, -3, -1, -2, -3. All right. We'll write them in here. -1, -2, -3. All right, and now, guess what we're going to do? Let's go back. Whoops, let's click on that. Just give me red. All right, what do we do now? Jump down here. What do you think we're going to do? Look, this was open at, it was open, 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 open. What's that going to be? Look, it's open, 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 open. Why would I go 4 opens and then put closed, okay? So it's open, 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 right? Now watch. If I go, watch this, then where's my next open going to be? Oh, I'm sorry, I lied. Yeah, no, that's good. I did that right. And then, look, I went down and down, right? I went down 1, down 1. That's going to be open right there. Then I go down 1, down 1. That's going to be open right there, okay? Where's the close going to be? See, it's closed at 3, 3, 2, 2, 1, 1, 0, 0, -1 what? -1, -1, -2, -2, -3, -3. See that? So all the integers, you're just going to put open or closed circles there. And then what are you going to do? You're going to go just to the right, completely to the right until you get to the next integer, and then you're going to put an open there. All right? Same thing with this. You're going to start at the closed, go to the open, start at the closed, go to the open. All right, and that's your function. That's how you graph it. It's kind of weird, but there's actually, and I think in the book they talk about it a little bit. I probably do you a little disservice by not doing a whole lot of these word problems, or if any of them so far. But it takes so long to go through those and explain them, and I just want you to get the general idea how to do this, and then maybe another class you can see how it applies. But it is applicable. There are things that this will apply to. I can't tell you exactly right now what they do, but there is an example in the book where you can use this kind of stuff. So it's actually used in real life under certain circumstances, right? So, but that's what it looks like. That's your step function, your greatest integer step function. Again, a step function is just a general one. This is specific to a greatest integer function, all right? So how would we do this? What if I asked you to graph this and you had to do this right here completely on your own? Here's what I would do, all right? Since it's just y equals x, what am I going to do? I'm going to go 1, 1, right? Because when x is 1, y is 1. Agreed? When x is 2, y is 2. So I'm going to go 1, 1, or 0, 0, 1, 1, 2, 2, 3, 3, and so forth. Then I'm going to go the other way. -1, -1, -2, -2, -3, -3. So I got my solid points in there. But what does this do? We don't just connect all those solid points. We go over to the right until we get to the next integer, put an open circle, and then you would jump up to the next one. Put a closed circle over until you get to the next integer, put an open circle. Then go up, put a closed circle, go over till you get to the next integer, put an open circle. Everybody see that? Yeah. At first, it is weird, right? You probably never saw that before, have you? Did you do that in Algebra 2? That's a possible, it's possible they teach that in Algebra 2 at some point. It just depends what book you use and all that kind of stuff. I don't know. But that's what a step function is. At my other school, I had a book. It was different than these, but yeah, we taught this. But again, like I said, that was 20 years ago. So it's amazing that I remember how to do it now. But it's really not that hard. It's not that bad, all right? Just put your solid points in there, and then just go to the right till you get to the next integer, put an open, then you just jump up. See how it just jumps up from 0 to 1, and then it would go from 1 to 2, from 2 to 3. That's all there is to it. Does it make sense? I can see it in your face, it doesn't. And nobody wants to say. But that's what they're going to ask you to do. All right, so now 1-7, now it's officially assigned, okay, because we've gone over everything on 1-7. So we'll take that on Monday, all right? So I'm going to turn this off. Maybe we'll look at a couple homework problems, and then we'll try to do those together to try to make you feel a little bit better. I can tell that you don't feel very comfortable with this. Am I right or not? Or it just is so easy, you're just bored out of your mind, and you're like, come on, give us something really challenging. No, you don't feel like that? Okay. All right, so what was that homework again? 3 to 20? I think yesterday I said to 22, right? It was 11 to 20. 11, sorry, 11. We'll just go to 20. Don't worry about 21 and 22. So let's just go 11 to 20.
Are we starting at the ones you said?
Section 1-7. Well, if you already done the other ones, you don't have to put it in order, right? Just put them on the back or put them on another piece of paper or whatever if you haven't done those. If you've done some of the other ones and feel good with them, just leave them right there, okay? All right, so you're just going to have 11 to 20 on there. Doesn't have to be in perfect order, but just make sure you get all these done. Okay,